Hello friends, today we are going to see the working of half wave rectifier. So what is half wave rectifier? So half wave rectifier, it is a rectifier which conducts only during the positive half cycle of the AC input. As shown in the diagram, here we are applying half wave rectifier AC input which consists of both half cycle, that is positive half cycle as well as negative half cycle. While at the output of half wave rectifier, we obtain only the positive part of the AC input. This negative part gets blocked by the half wave rectifier. So the definition of the half wave rectifier circuit, it is a rectifier which conducts only during the positive half cycle of the AC input. So the definition of half wave rectifier is a rectifier which conducts only during positive half cycle of AC input. It is called as half wave rectifier circuit. So we are going to see now the circuit diagram for half wave rectifier circuit diagram. It consists of step down transformer, one diode and load resistance RL. So the circuit diagram is like this. So I am drawing now the symbol of step down transformer. So it is the step down transformer. Here it is diode D, load resistance RL, and here it is the output voltage VO. Also, you have to show the two terminals of secondary of the transformer, that is terminal A and terminal B, and we are applying 230 volt AC as an input to the rectifier. We know that rectifier, it is a circuit which converts AC quantity into DC quantity. Okay, that is alternating current or voltage into direct current or voltage. So operation of the half wave rectifier, it is basically on two parts. That is the first part, operation during positive half cycle, and second part is operation during negative half cycle. So we have to analyze this half wave rectifier during the two portion of AC input, that is operation during this part, that is during positive half cycle, and operation during this part, that is negative half cycle. So first we will see the operation during the positive half cycle, that means this part. So for that purpose we have to again redraw the half wave rectifier circuit like this, which is called as equivalent circuit of half wave rectifier. Then here it is diode D, load resistance RL, and here it is V output. So I am showing the output voltage VO like this. As we are seeing the operation during the positive half cycle, that is from this portion to this portion. So this portion is from 0 to pi. So we are seeing this first part, that is from 0 to pi. What will happen at the output of the half wave rectifier? So I am applying the 230 volt AC input. So I am drawing only the positive half cycle of this input signal. So here it is the positive half cycle of the input signal. So during the positive half cycle of the supply, the terminal A, that becomes positive with respect to terminal B. That means terminal A becomes positive and terminal B becomes negative. So here it is the anode of the diode and here it is the cathode of the diode. So anode is supplied with the positive voltage while cathode is supplied with the negative voltage. Hence this diode D, it is forward bias during the positive half cycle. As we know that diode is a unidirectional device, so it conducts only in one direction. So current that will flows through circuit through diode D through load resistance RL, and circuit is completed at terminal B, which is negative. always remember that the current that is always flow from positive to the negative. So we have shown the current starting from terminal A, which is positive, that goes through diode D. As diode D is forward biased, hence it conducts, it acts as a closed switch, hence current flows through this diode D through load resistance RL and terminated at point B, that is negative terminal. So across the load resistance RL we obtain the output voltage. Okay, so the terminal voltage, that is VAB, that is between terminal A and B, you can easily see from looking at the these waveforms of half wave rectifier. It is the secondary voltage VAB during the positive half cycle as diode conducts, hence we get the load voltage across the load resistance RL. Load voltage is nothing but the output voltage, which is shown by this on y-axis VL. So positive half cycle, it is shown here load voltage. As load voltage exists, load current also exists. So during the period of operation during positive half cycle from 0 to pi, we obtain the load voltage as well as load current here. Okay, so now we are going to see the operation during the negative half cycle. What will happen during the half cycle? So let us redraw the equivalent circuit. So I am redrawing the equivalent circuit for negative half cycle. Okay, so I am drawing here as an open switch. I will tell the reason why I am drawing this diode as an open switch. So I am redrawing the waveform. I am redrawing the circuit. So during the negative half cycle, what will happen? Let us see. So during the negative half cycle of AC input, the terminal A becomes negative with respect to terminal B. Okay, as terminal A is negative with respect to terminal B, hence anode is supplied with the negative charge while cathode is supplied with the positive charge, and diode is reverse biased. And we know that when the diode is reverse biased, it acts as an open switch, it does not conduct at all. So hence the circuit is disconnected here, as you are seeing this in the diagram. So load is disconnected from this secondary winding. So the output voltage during the negative half cycle is 0, as load is disconnected from the secondary winding. So no voltage or no current is supplied to the load, hence the output voltage is 0. So you are easily seeing into this diagram during the negative half cycle. Okay, as diode does not conduct at all, so load voltage is 0 as well as load current is 0. Again, next positive half cycle, again the process repeat, that is during the next positive half cycle, again diode becomes forward biased and hence it conducts, as well as we can obtain load voltage and load current. So like that the process repeat itself, hence the working of half wave rectifier.